So now we're going to talk about trying to prove a rectangle, rhombus, or square. So to do that is a little bit harder. You have to remember some more of the properties to do that. So I'm going to go over what the most common ones to do are first, and then we're going to try one of each of these proofs. So first is proving a rectangle. So pause the video here and write this stuff down, or you can listen first and then write it down. When you are proving a rectangle, the most common ways to do that are, first of all, if you can get it to be a parallelogram first, then all you need to do is get it to have one right angle, and then you know it's going to be a rectangle. And the reason is because once you know it's a parallelogram, you know that your opposite sides are congruent, and you know opposite angles are congruent. So if I have one right angle, I know the opposite angle from that is going to be another right angle. I also know consecutive angles are supplementary. 180 minus 90 is 90. And again, opposite angles are congruent here. So having one right angle in a parallelogram gets me 4 right angles in a parallelogram, which makes a quadrilateral a rectangle if it has 4 right angles. The other way of doing it is to get the parallelogram to have congruent diagonals. And if you can do that, then you know it's a rectangle as well. The other way is if you have just a quad, so you don't get it to be a parallelogram first, and then you get it to have 4 congruent angles. So you get it to be equiangular. And if you have a quad with all 4 angles that are congruent or equal, then you know it's a rectangle. All right, so let's try a proof here. So we're given segment AEBF. We're given, so just saying it's a straight line, we're given ABCD is a parallelogram, segment DE is perp to AB, and segment CF is perp to AB. So I'm going to draw our picture here. So that's D, C, F, B, E, and A. So pause here, write down your given and your prove and your picture. Go ahead and mark your givens on your picture as well. And start to think of a plan as to how you might be able to prove that DEFC is a rectangle. All right, so we know, I'm going to highlight ABCD. I know that's a parallelogram. I know that segment DE is perp to segment AB. And I know that segment CF is perp to segment AB, and AB has just been extended to F. So I have right angles right there. And in green, I'm going to put what I'm looking for. So DEFC, I want to be a rectangle. So if I can first get this to be a parallelogram, then looking at my picture, I already see that I have a right angle right here. So if I can get DEFC to be a parallelogram, I can get it to have one right angle, which means it's a rectangle. So now let's figure out how to get it to be a parallelogram first. So we haven't used our given yet that ABCD is a parallelogram. So that's the blue shape here. So if I know that this blue quad is a parallelogram, I know opposite sides are parallel. Now if you notice here, the blue and the green lines lie right on top of each other. Just on the bottom here, the green extends past the blue extends past the green in the other direction. And if we know that those two lines, the blue lines are parallel, then we know those green lines are also parallel. So now we have a set of parallel lines, part of our green quadrilateral so far. All right, so knowing that, I'd say to myself, well, if I can get segment DC congruent to segment EF, that would get me a parallelogram because I have one pair of sides both congruent and parallel. But it looks like it might be tricky to get segment EF there congruent because it doesn't quite line up with the blue, and I don't know that much information about the segments on the bottom there. I could also try and get segment DE parallel to segment CF. And then if I could get them parallel, I'd know I'd have 2 pairs of opposite sides parallel, making the green quad a parallelogram. Well, how could I get those to be parallel? All right, well, looking at our picture, I see here that I have these right angles. And I know that if I have two lines perpendicular to the same line, then they're parallel to each other. So that tells me that these two sides must be parallel, making that a parallelogram because both pairs of opposite sides are parallel. Then making it a rectangle because it's a parallelogram with actually two right angles here, but at least one right angle. All right, so we've got enough information to go. So if you are feeling confident, I would please encourage you to please try it on your own. Write out the proof and then come back to the video to check. All right, so first I'm going to just conclude from my given here, so I have that out of the way. Segment DEB and segment CFE are right angles. And our reason there, perp lines form right angles. So that one comes up a lot. All right, now we need to get that DEFC to be a parallelogram. So one thing we said is that segment DC is parallel to segment EB, or in this case, segment EF, they're the same thing. And our reason there, those are parallel because they're part of the ABCD parallelogram. So in a parallelogram, opposite sides are parallel. So now that gives me one pair of parallel sides, but in order to be a parallelogram, I need two pairs of parallel sides. So now I can say segment ED is parallel to segment CF, and this one we don't use as often in our proofs, but if two lines are perpendicular to the same line, then they're parallel to each other. So now I have both pairs of opposite sides parallel to each other. So I can now say that DEFC is a parallelogram. Why? If both pairs of opposite sides are parallel, the quad is a parallelogram. And then we're trying to prove that DEFC is a rectangle, which again, if we can get it to be a parallelogram with a right angle, we have a rectangle. So now I have that it's a parallelogram, and I have that an angle inside of that parallelogram is a right angle. So I can say if a parallelogram has a right angle, then it's a rectangle. So you can get it to have 4 right angles, but you don't need to. And in this case, we don't have enough information to get 4, so we only need to get 1 right angle there. All right, let's try another type of proof, proving a rhombus. So to prove a rhombus, again, we first typically get it to be a parallelogram. So we get it to be a parallelogram, and then once it's a parallelogram, what makes a rhombus special is that it has those 4 congruent sides. But using your properties of a parallelogram, we already know that opposite sides are congruent. So if I can just get a pair of consecutive sides, meaning a pair of sides that's next to each other to be congruent, that means all 4 will be congruent. So we're always looking for the least amount of work we can do to get it, because we may not be given enough information to get all 4 sides congruent. Now, if you can say that if the quad is equilateral, meaning it has all 4 congruent sides, this is the third one, then it's a rhombus. But sometimes we don't have enough information. So you also could get it to be a parallelogram first, and then just 2 congruent consecutive sides. Consecutive, again, meaning next to each other. And the third way here is if the parallelogram has perpendicular diagonals, then it would be a rhombus. And that one is probably not used as frequently, I'd say this would be the main one that we're going to be using. All right, so if you haven't already, pause the video and copy those down if you didn't finish. For number 4, I have your givens written up here. I'm going to draw the picture as well. So pause the video here and write down your given, your proof, your picture, mark your givens, and see if you can try and get this proof on your own. So pause it and give it a try. All right, so we've got segment AB. This one is a little hard to read. It's DC, and it's congruent to BE. So all 3 of those segments are congruent. 1 and 2 are congruent. And then 3 and 4 are congruent, but not congruent to 1 and 2. We want to get, so in green, I'll put what I'm looking for, A, B, C, D to be a rhombus. Okay, so I need to try to get that green quad to be a parallelogram first, and if I can get it to be a parallelogram, then I want to get 2 congruent consecutive sides. So let's just start looking at what we were given, see what we can conclude, mark our pictures, and then try to make a plan. So first, something that pops out at me is the angles 3 and 4, because right away I kind of see that Z pop out here. So if my all interior angles are congruent, then I know that the lines that formed them are going to be parallel to each other. So if I have a pair of lines that's both parallel and congruent in a parallelogram, then I have myself a parallelogram. So that would be enough information to get A, B, C, D to be a parallelogram. Once it's a parallelogram, though, I need it to have 2 congruent consecutive sides. So right now, I only have a pair of opposite sides congruent, but I haven't used my givens yet, all of them. I concluded from this one, and I've kind of used the first one, but I haven't used all of it yet. I haven't talked about segment BE yet. So let's look at angle 1 congruent to angle 2. So why did they give me that given? What can I conclude? So you might notice there that 1 and 2 are part of a triangle. And if those base angles are congruent, then it's an isosceles triangle. So we know in a triangle, sides opposite congruent angles are congruent. Now, when I mark that other side congruent, now I see that if that's congruent to segment BE and BE is congruent to segment DC, I now have 2 sides next to each other, 2 consecutive sides in my parallelogram, which would make it a rhombus. Now that we've kind of discussed it, if you need to rewatch part of that to see how we got there, do so, and then try to rewrite this on your own. All right, I've got my given written out, and now I'm going to, I'll start with what we left off here saying segment BC congruent to segment BE. In a triangle, sides opposite congruent angles are congruent. So that gives me those 2 sides congruent. Now I can get segment BC congruent to segment DC. You also could have done segment BC congruent to segment AB. It doesn't matter which one. And the reason for that one, you could either do substitution or transitive property would have been fine there. Next, I've got 2 congruent consecutive sides, but I need it to be a parallelogram in order for it to be a rhombus. So I need a parallelogram with 2 congruent consecutive sides. So I already have segment DC congruent to AB right here. So I have a pair of congruent sides. So if I can get those same sides to be parallel, which I can, then I've got myself a parallelogram. So step 4 would be, if the all interior angles are congruent, then the lines are parallel. So make sure you start with if the all interior angles are congruent, and then the lines are parallel. Now I have a pair of parallel sides. So if I have a pair of parallel sides and that's the same pair of sides that's also congruent, then I know that ABCD is a parallelogram. Because if one pair of sides is both parallel and congruent, so it has to be the same pair of sides, then the quad is a parallelogram. So now I've gotten this to be a parallelogram. I'm trying to get it to be a rhombus. So I have a parallelogram and I have two congruent consecutive sides. So I have enough information to say ABCD is a rhombus. And your reason for that should be if a parallelogram has two congruent consecutive sides, then it's a rhombus. So again, a lot of studying, a lot of memorizing here, again, with these properties. So you need to know your 5 properties of your parallelogram. Opposite sides congruent, opposite sides parallel, opposite angles congruent, diagonals bisect each other, and consecutive angles are supplementary. Make sure you have those 5 memorized. Then you also need to now know that a rectangle is a parallelogram with 1 right angle. You need to know a rhombus is a parallelogram with 2 congruent consecutive sides. And if you know those and you study those, it'll make being able to do these a lot easier and also a lot faster. All right, the last one we'll do here is proving a square. So to get something to be a square, a square is a rectangle and it's also a rhombus. So to get it to be a square, you have a couple options again. You could get it to be a rectangle first with 2 congruent consecutive sides. So think about a rectangle. So why is a rectangle not always a square? Well, they both have 4 right angles, but a rectangle doesn't have 4 sides congruent. So if you can get a rectangle to have all 4 sides congruent, then it's going to be a square. Now, just because a rectangle is already a parallelogram, you already know the opposite sides are congruent. So if you, again, just get 2 congruent consecutive sides, so if I just get 2 sides congruent that are next to each other, then that means all 4 would be congruent. And I don't have to prove all 4 congruent if I get 2 congruent consecutive sides. I also can get it to be a rhombus first. And then why is a rhombus not always a square? Well, because a rhombus does not have right angles. So if we can get it to be a rhombus, which has 4 congruent sides, and also have a right angle, then it would be a square. And the last way here is that if you take a quad and you get it to be both a rectangle and a rhombus, then it's also a square. That usually takes an extra step to do that, so I didn't write that one out. So at this point, pause your video, make sure you have all of that written down for a square. All right, and then next, copy down your givens, your picture, and go ahead, mark your picture, and try to take the proof as far as you can go. Make your plan. Again, with proofs, it's extremely important that you're able to do them on your own and start them on your own. So the more you practice and even, get things wrong at first, maybe skip some steps and then correct those, that's how you're going to learn to be better at proofs, because you're going to realize what mistakes you make. If you're always just copying them, you don't know what mistakes you'll make on your own until you come to a test or quiz. All right, so we're given quad ABCD, which doesn't really help us. We're given segment AM congruent to segment MC, DM congruent to segment MB, segment AB congruent to segment AD, and an ABC is a right angle. We want to prove that ABCD is a square. So based off of what we just talked about, we need to get it to be a rectangle or a rhombus first. And in this proof, you could do either way that you wanted. So in order to get it to be a rectangle or rhombus, we first have to get it to be a parallelogram. So looking at our givens, how could we possibly get this to be a parallelogram? I'm not given opposite sides congruent or parallel. I'm not given any all interior angles. But what I am given is that these 2 here are congruent and these 2 here are congruent, which tells me that these diagonals must bisect each other. And one of our properties of a parallelogram is that the diagonals bisect each other. So I could then say, we'll talk about it first and then write it out. So we could get this ABCD to be a parallelogram because the diagonals bisect each other. All right, so once it's a parallelogram, now I could get it to be a rectangle because I have a parallelogram with one right angle, which makes it a rectangle. And then to get it to be a rhombus, if a rectangle has two congruent consecutive sides, which we do right here, it's then a rhombus. So not a whole lot of concluding besides getting it to be the parallelogram. Everything else is kind of given to us. Another way you could have done it is get it to be the parallelogram because the diagonals bisect each other again. You could have then said it's a rhombus because it's a parallelogram with two congruent consecutive sides. And then it's a rectangle, or it's a square because it's a rhombus with one right angle. All right, now that we've kind of talked it through, pause it if you haven't already and try to write this out and then check back with the video after that. Okay, so we've got segment DB and segment CA bisect each other. So you need to write that out first before you go right to saying that it's a parallelogram. And the reason we can say they bisect each other is, I would take here just definition of a segment bisector. So we know that segment bisectors will split our segments into two congruent parts. Once I know my diagonals bisect each other, I have enough to say that ABCD is a parallelogram. Because if the diagonals of a quad bisect each other, then it's a parallelogram. Now I have a parallelogram. So again, you have a couple options. I'm going to choose one. I'm going to go with saying that it's a rectangle first. So ABCD is a rectangle. And here we'd say it's a rectangle because if a parallelogram has a right angle, then it's a rectangle. And we have that right angle right here. And we have a parallelogram right here. And then step 5, I can now go straight to saying ABCD is a square because a rectangle with two congruent consecutive sides, which again were already given to me right here. So I have two congruent consecutive sides. And I have that it's a parallelogram, and I have that it's a rectangle right here. So a rectangle with two congruent consecutive sides is a square. So if a rectangle has two congruent consecutive sides, it's a square. Now again, after step 3, you could have said for step 4 that ABCD is a rhombus. If you did that, the reason would be if a parallelogram has two congruent consecutive sides, then it's a rhombus. And then step 5 would be it's a square because if a rhombus has a right angle, then it's a square. Another option, which would be an extra step, is step 5, you could have then said ABCD is a rhombus because if a parallelogram has two congruent consecutive sides, then it's a rhombus. And then step 6 would be that it's a square, ABCD is a square, because if a quad is a rectangle and a rhombus, then it's a square. So either of those, any of those 3 ways would have worked to get this to be a square. So again, remembering your family tree of your quadrilaterals is important and helpful here when doing these proofs as well. All right. Make sure you practice these, redo them again if you weren't able to get them on your own. See me with any questions, and pie out.